All right, everybody. So I normally like to teach and make videos where I've done a lot of the workout beforehand because I think it has a better flow than is if it otherwise if I'm writing everything down as I'm saying it or typing things out or working problems that I have no idea where they're going. It can be a little bit awkward and slow. So I like to put a lot of prep in. I spend more time making the slides and so on for the videos, way more time than I ever spend actually making the videos. But uh, there, right now, I really think that I should do a problem from my math lab, just step by step. Okay. Now, this is based on the problem type where there's a population of some kind and we don't know the mean or the standard deviation of the population. And we take a sample, and from the sample, we calculate the mean and the standard deviation. Okay? And we use that to make a confidence interval to express a probability of what the mean of the population is. Okay? So that's a video I've just made. And hopefully by the time you're watching this video right now, you've seen this other one. Okay? It would be necessary to have watched this other one to know what I'm going to do now. So I have like a blank slate here to do my work and so on. But let's see, here's the problem. It says the monthly incomes of 12 randomly selected people, each with bachelor's degrees in economics, are shown on the right. Complete parts A through C below. All right, so, and it says assume the original population is normally distributed. So that turns out that has to be part of the fine print for solving this type of problem where we don't know the mean or standard deviation of the population. We calculate the mean and standard deviation of a sample and use that to estimate the population mean. There's lots of fine print, like the sample has to be maybe a certain size, or the population that you're studying has to be normally distributed in the first place. But we can take that for granted now. So first it says calculate the sample mean. Well, yeah, because but let's go back to this problem. I mean, I did say you have to watch this other video, but just so it's on your mind right now. I said, well, what I did, I wanted to study the population of house cats and know something about their average weight. So what I did was I took a sample of 40 house cats, maybe at a veterinary research lab or something like that. And I weighed them all, and I calculated their mean weight and the standard deviation weight. Okay, so yeah, you got to know that about your sample. So let's see. I mean, I guess I could like write all these numbers down and so on, but I'm not gonna do it that way. That takes too long. I'm gonna open it in StatCrunch. I'm gonna do it that way. So let's see. There are my numbers. Okay. Now I'm gonna do calculators and summary stats. Sorry, summary stats columns, and I select the column VAR1 because that's where my data is. And let's do the mean because it asked for that. I have a feeling it's going to ask for the standard deviation too. Okay. All right. So let's compute that. See, so here's the mean, 4263.18. Okay. And standard deviation 259.96. All right. So let me write those down. So I said this video might be a little awkward because I'm going to be doing it this way. 259.965. Okay, so I wrote down the mean and the standard deviation. And the sample size is 12. I'll probably need that number too. Okay, so I got those numbers written down. I'm going to close this. And I'm going to close StatCrunch too. All right, so it means it's round to one decimal place. So let's see, that'd be 4263. The number I got, let me write down for you to see, because these are the numbers I'm going to be using. 4263.183. and that was the sample mean. The sample standard deviation, 259.965. Okay, and then the sample size was 12. Now, it says over here in this question in my math lab to round to 1 decimal place. Well, so if I got 4263.18, then round to 1 decimal place, that'd be 4263.2. So let's do that. 4263.2. Okay, and whoops, move this. So let's check our answer. Okay, got that right. Sample standard deviation. I've done that already too, and it says round to 1 decimal place. But I got 259.965. Well, if I round that to 1 decimal place, you know, that 9's got to go up 1 digit, but that would bring it to a 0. And then this would go up 2, all right? So that'd be 260.0 if I round to 1 decimal place. All right, so let's see, 260.0. And okay, got that too. And then it says construct a 90% confidence interval for the population mean. So I want to estimate of all people with bachelor's degrees in economics, the whole population, not just these 12, but the whole population, can you say with 90% confidence what their average monthly salary is? That's what this is asking us for. Well, let's go back over here to our work. So the confidence interval will be done like this. We would say x bar minus TC S over N, and that would be the low end of our estimate, and then x bar plus TC times S, oh, well, not N, root N, okay? Where this number right here is called the margin of error. Now, I'll have to find that in parts. First, TC, that comes from the T distribution. Okay, so let's do like this. First, TC, that will come from a T distribution with 11 degrees of freedom. Okay, so let's do that. Oh, and 90% confidence. So let's go back to StatCrunch. So this time I'm going to say I want T distribution calculator, okay? And it was 11 degrees of freedom and 90% confidence. Okay, whoops, in between. So 1.7959, that is my critical value for my confidence interval. So TC, too many numbers to remember. What was it? 1.7959. Okay, so that's that number. Next, let's do this margin of error. TC times S over root N. Now, just found the critical value, 1.7959, okay? And then S, that was 260. Remember when we rounded it and I put it in my math lab before? And then root N is going to be root 12. Okay, now I'm using that rounded value, like I suppose it wants me to use the number that it's already asked me for. So that's why I'm doing it that way. Okay, now, so let's see, I figure out what that is, 1.7959, okay, times 260. Okay, then divide by root 12, all right, handheld calculator, enter that, and I get 134.792, okay? 134.792, right? I don't write down more numbers than I think I need. Okay, so that's my margin of error then. now it's from this, I can get that confidence interval, okay? Because what I'm supposed to do is take the sample mean, which was 4263.2, and I'm going to add and subtract this number to it. Okay? And again, I'm using for the sample mean the number my math lab has already asked me for, which was 4263.2. It was rounded to 1 decimal place. And then I'll do plus E. Okay, where that's this number right here. Okay, so let's do that. 4263 minus, 0.2 minus 134.7922. And I put more digits than I think I'd actually need just to be safe. So I'll get 4128.4. Okay. Okay, so that's this one, 4128.4. And then the high end of my estimate will be 4263.2 plus my margin of error, which is right here, 134.7922. And I get 4397.99. 4397.9922. All right, I'm writing more numbers down than I think I actually need. Now, that's my confidence interval. It's like for the population of all economists, all people that have bachelor's degrees in economics, whatever it said. I don't know what their average monthly salary is, but I can say with 90% confidence, it's somewhere between 4,128.4 and 4,397.99. Okay, I can tell you that with 90% confidence. Now, as far as my math lab goes, what did it say? Round to 1 decimal place? Well, let me put that in, just to show you. 4128.4. When I wrote that down, I did round that to 1 decimal place because I thought that's what it said. 4128.4. So let's see. There goes with that number. 4128.4. All right. And then that number on the high end, it also says to round to 1 decimal place, but with 4397.99, I'm going to round that up, and it'll become a 0, and I'm going to round this up, and it'll become an 8. So 4398.0 will be rounding that to 1 decimal place. 4398.0. So let's see, 4398.0, and whether or not you have to actually put the 0.0, I kind of doubt it with my math lab, but I'm putting it anyway. So that's my confidence interval that I found with my own calculations on scratch paper, put in and rounded appropriately on my math lab. So let's check it. So then correct. Okay. So that's how you would go through this whole process that I described in my first video on this subject. You got a population, you don't know the mean and the standard deviation. You take a sample of a certain size. From the sample, calculate the mean and standard deviation with StatCrunch. Not hard to do with StatCrunch. Go ahead and do that the way I showed you. And then use these formulas in the last video and the procedure there to calculate the confidence interval. Okay, so that's problem start to finish in my math lab. I don't really like to do it that way, but still I hope it helped you to see one start to finish, kind of awkwardly worked out by me. If that helps you more than the way I've been doing videos, let me know. I can make more videos that are like that. I make them so that they work for you. So if you have any feedback, let me know.